The Big Bang took place with the explosion of the point, which contained all the matter and energy of the universe, and its dispersion into space in all directions with a terrifying speed. Out of this matter and energy, there came about a great balance containing galaxies, stars, the sun, the earth, and all other heavenly bodies. Moreover, laws were formed called the laws of physics, which are uniform throughout the whole universe and do not change. The laws of physics that emerged together with the Big Bang did not change at all over a period of 15 billion years. Furthermore, these laws stand on calculations so scrupulous that even a millimeter's variation from their current values could result in the destruction of the whole structure and configuration of the universe. All these indicate that a perfect order arose after the Big Bang. Explosions, however, do not bring about order. All of the observable explosions tend to harm, disintegrate, and destroy what is present. If we were to be introduced to a very detailed order after an explosion, we then might conclude that there was a planned creation behind this explosion, and that all the pieces dispersed by the explosion had been made to move in a very controlled way. The quote from Sir Fred Hoyle, who finally had to accept the theory after many years of opposition to the Big Bang theory, expresses this situation very well. The Big Bang theory holds that the universe began with a single explosion. Yet, as can be seen, an explosion merely throws matter apart, while the Big Bang has mysteriously produced the opposite effect, with matter clumping together in the form of galaxies. No doubt, if a great order arose with an explosion, then it should be accepted that the intervention of a creator is involved in every moment of this explosion. Another aspect of this extraordinary order formed in the universe following the Big Bang is the creation of a habitable universe. The conditions for the formation of a habitable planet are so many and so complex that it is impossible to think that this formation is coincidental. Paul Davies, a renowned professor of theoretical physics, stated at the end of the calculations he made on the expansion rate of the universe that this rate is inconceivably delicate. Davies says, "Careful measurement puts the rate of expansion very close to a critical value at which the universe will just escape its own gravity and expand forever. A little slower, and the cosmos would collapse. A little faster, and the cosmic material would have long ago completely dispersed." The Big Bang was not, evidently, any old bang, but an explosion of exquisitely arranged magnitude. The famous physicist Professor Stephen Hawking states in his book, A Brief History of Time, that the universe is set on calculations and balances more finely tuned than we can conceive. Hawking states, with reference to the rate of expansion of the universe, if the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in 100,000 million, the universe would have recollapsed before it ever reached its present size. Paul Davies also explains the unavoidable consequence to be derived from these incredibly precise balances and calculations. It is hard to resist the impression that the present structure of the universe, apparently so sensitive to minor alterations in the numbers, has been rather carefully thought out. The seemingly miraculous concurrence of numerical values that nature has assigned to her fundamental constants must remain the most compelling evidence for an element of cosmic design. In relation to the same fact, an American professor of astronomy, George Greenstein, writes in his book, The Symbiotic Universe, "As we survey all the evidence, the thought insistently arises that some supernatural agency must be involved. Briefly, when we examine the glorious system in the universe, we see that the existence of the universe and its workings rest on extremely delicate balances and an order too complex to be explained away by coincidental causes. As is evident, it is by no means possible for this delicate balance and order to have been formed on its own and by coincidence after a great explosion. The formation of such an order following an explosion such as the Big Bang is a clear evidence of a supernatural creation. This matchless plan and order in the universe certainly proves the existence of a creator with infinite knowledge, might, and wisdom, who has created matter from nothing and who controls and manages it incessantly. This creator is Allah, the Lord of all the worlds.
Less than a billionth of a second after the Big Bang, a bubble much smaller than a fraction of an atom forms. This is the universe. It is unimaginably small and unimaginably hot. Within this bubble, the four known forces of nature: gravity, electromagnetism, plus the strong and the weak nuclear forces, are a combined superforce. Gravity suddenly splits off from the superforce as the universe expands. As the universe expands, it cools, which somehow sets off a burst of energy, fueling the hyperinflation of the universe, suggested by Alan Guth. This inflation locks in the uniformity of the universe pictured by the WMAP satellite. The universe is still less than a second old when the superforce decays into the separate forces of nature. Roughly 3 minutes after the Big Bang, the temperature of the universe has dropped to a mere 1 billion degrees Fahrenheit, cool enough for atomic nuclei to form. The element hydrogen forms. Some hydrogen atoms fuse to create helium, as proposed by Gamow and Alpher. 380,000 years later, and light travels through the darkness. The burst of radiation that Penzias and Wilson found happens now. A billion years after the Big Bang, stars take shape, producing the heavier elements like nitrogen, oxygen, and carbon, as Hoyle predicted. Roughly 9 billion years out, matter and gravity combine to form a perfectly typical star. Pressure creates heat at its core. This heat triggers thermonuclear fusion. A star is born. Stellar outflow clears away residual gases. A circumstellar disk of dust remains that eventually accrete into an entourage of planets and moons. One of these lumps of stardust, after being pummeled for eons by residual solar debris, has temperatures warm enough to allow hydrogen dioxide, water, to build up in the atmosphere. Liquid water gathers on the planet's surface. Underwater, mysterious chemical reactions ultimately form life. 13.7 billion years after the Big Bang, our universe is now 156 billion light years across. The sky is full of stars. Our solar system has 8 planets, more or less. The third planet is nearly covered in carbon-based life forms. Some are just realizing what infinitely small specks they are in the grand scheme of things.
News surrounding major religions has been front and center the last few weeks. Just moments ago, we looked at the outrage and in some instances violence that resulted in part because of a film insulting Islam and the Prophet Muhammad. But right now, we wanted to take a different look at religion and science for this week's Faces of Faith. Cosmologist Lawrence Krauss joins me now from London. He is the author of A Universe from Nothing. Lawrence, good morning. Nice to have you back on the program this morning.
It's always good to be back.
Let's talk about this whole idea of nothing. Explain your book, if you will, first of all. I mean, you say the universe was created without the hand of God, and that science can explain why everything exists. So explain that.
Well, let me make it clear. I say it's plausible that it was created without God. I think that's what's worth celebrating, is the fact that we can see some plausible steps. We don't know all the answers, and I don't claim we know all the answers, but even the fact that the laws of nature themselves could have created everything we see, all 100 billion galaxies, each containing 100 billion stars, from nothing, is absolutely remarkable. And the discoveries that have made that possible, that idea possible, are worth celebrating. The point is that we've kind of realized after 100 years of studying the universe that the total energy of the universe could be precisely zero. And if you were going to create a universe from nothing, that's probably a good first step. The laws of quantum mechanics tell us that empty space is a boiling, bubbling brew of virtual particles that pop in and out of existence in a timescale so short you can't see them. Strange things can happen, and in fact, it's possible, without any supernatural shenanigans, for matter and particles to be created from nothing. It's even possible that space and time themselves popped into existence from nothing. It's allowed by the laws of physics. And that is so remarkable that we shouldn't feel it's a threat. We should celebrate this new discovered knowledge.
Okay, so for those folks at home who just listened to that and they're shaking their heads saying, what? How is this guy saying that something could come from nothing? Are you saying that there's energy in that nothing, in that space?
You don't, well, in fact, what's really remarkable is once you put gravity into the mix, you can have positive energy and negative energy, and you can start out with zero energy and then create positive energy particles that have positive energy, but their gravitational attraction has negative energy, and the sum total can be zero. It sounds like the ultimate free lunch, and it potentially is. Now, these things are strange, but the world of quantum mechanics is extremely strange. But we rely on it for the semiconductors that allow me to talk to you right now. And the fact is that nature, the real universe, is stranger than we could have imagined. It's in fact far more interesting than the fables produced by Iron Age peasants who wrote them down before they even knew the Earth orbited the sun, for example.
So what do you say, though, when people say, you know, maybe the notion of nothing creating something, that sounds every bit as unbelievable as saying that God created all this. What do you say to those people?
Well, what I say is that the real difference is that we're not presuming the answers before we ask the questions. When you say God did it, it's really kind of a lazy result saying, well, I don't know where it came from, and I'm going to assume intentionality, which is really what our ancient ancestors always assumed. They assumed that everything that happened had some intention. But what we've discovered is that we've been driven to these amazing discoveries. For example, here's an observational discovery that defies common sense. We have discovered, and one of the reasons I wrote the book, is we've discovered that empty space itself, empty space, getting rid of all the particles and all the radiation, empty space weighs something. In fact, it has the dominant energy in the universe. It's causing the universe to expand ever faster, faster and faster. The discovery was so amazing that it was awarded the Nobel Prize last year. Now, that sounds crazy, but it's true. And I think the point is that we have to force our beliefs to conform to the evidence of reality instead of deciding this is the universe we want and we're going to force reality to conform to that. The universe doesn't care what we want. And one of the beauties of science is it's forced us to change our attitudes about many things. It's forced us to open our minds. And I think that's one of the great aspects of science, is that we've learned that our preconceptions aren't always right. And certainly, as I say, that, you know, that we didn't know the truth before asking the universe what the truth is.
So then is science compatible with religion in any way?
Well, look, I can't argue that there's no purpose to the universe. I can say there's no evidence of purpose to the universe, but there could be purpose that I don't know about. But the point is that what we can say is that if there is purpose, it is strongly hidden, and we don't need any supernatural miracles to create everything we see. I think in terms of a vague deism, science and religion are compatible in that sense. But in terms of, in fact, the actual doctrines of the world's religions, Science is not compatible with them. The miracles of the Bible are inconsistent with science. But I think most people who claim they're religious don't really think Jonah lived inside of a whale, or don't believe actually that when a priest blesses a wafer, it really turns into the body of Jesus Christ. I think they kind of throw out the things that they think are silly, and they keep the things they like because they want to believe them. And I think that's the main thing. People want to believe that someone's taking care of them, that the universe is a place where somehow they have some meaning. And in fact, what I would argue is if we realize that we create the meaning in our own lives, our lives can become, in fact, richer than believing in these fairy tales.
So just to be clear, though, are you saying there is no God, or that you just believe that the universe was created without the hand of God?
Well, I'm not making grand claims that in either case. I'm not saying there is no God. I'm saying there's no evidence for God. You don't seem to need a God to create a universe. And in fact, in that sense, I personally wouldn't call myself an atheist, because I don't presume to claim there's no God. If anything, I declare myself as an anti-theist, because I can't say with absolute certainty there is no God. But what I would say is I'd much prefer to live in a universe without one.
Lawrence Krauss, always great to have you on the show. Always a fascinating discussion. Thank you so much, and best of luck with your new book as well, Universe from Nothing.
Thanks.
And for more stories on faith, be sure to check out our widely popular belief blog at cnn.com/belief.
There is nothing bigger or older than the universe. The questions I would like to talk about are: 1. Where did we come from? How did the universe come into being? Are we alone in the universe? Is there alien life out there? What is the future of the human race? Up until the 1920s, everyone thought the universe was essentially static and unchanging in time. Then it was discovered that the universe was expanding. Then it was discovered that the universe was expanding.
والسماء بنيناها بأيد وإنا لموسعون
والسماء بنيناها بأيد وإنا لموسعون.
Distant galaxies were moving away from us. This meant they must have been closer together in the past. If we extrapolate back, we find they must have all been on top of each other about 15 billion years ago. This was the Big Bang, the beginning of the universe. This was the Big Bang, the beginning of the universe.
أولم ير الذين كفروا أن السماوات والأرض كانتا رتقا ففتقناهما وجعلنا من الماء كل شيء حي أفلا يؤمنون.
But was there anything before the Big Bang? If not, what created the universe? Why did the universe emerge from the Big Bang the way it did? We used to think that the theory of the universe could be divided into two parts. First, there were the laws like Maxwell's equations and general relativity that determine the evolution of the universe, given its state over all space at one time. And second, there was the question of the initial state of the universe. We have made good progress on the first part, and now have the knowledge of the laws of evolution in all but the most extreme conditions, but until recently, we have had little idea about the initial conditions for the universe. However, this division into laws of evolution and initial conditions depends on time and space being separate and distinct. Under extreme conditions, general relativity and quantum theory allow time to behave like another dimension of space. This removes the distinction between time and space, and means the laws of evolution can also determine the initial state. The universe can spontaneously create itself out of nothing. the universe can spontaneously create itself out of nothing. Moreover, we can calculate the probabilities that the universe is created in different states. These predictions are in excellent agreement with observations by the WMAP satellite of the cosmic microwave background, which is an imprint of the very early universe. We think we have solved the mystery of creation.
يوم نطوي السماء كطي السجل للكتب كما بدأنا أول خلق نعيده وعدا علينا إنا كنا فاعلين.
I now turn to the second big question. Are we alone, or is there other life in the universe? We believe that life arose spontaneously on the Earth, so it must be possible for life to appear on other suitable planets, of which there seem to be a large number in the galaxy. But we don't know how life first appeared. We have two pieces of observational evidence on the probability of life appearing. The first is that we have fossils of algae from 3.5 billion years ago. The Earth was formed 4.6 billion years ago and was probably too hot for about the first half billion years. So life appeared on Earth within half a billion years of it being possible, which is short compared to the 10 billion year lifetime of a planet of Earth type. This suggests that the probability of life appearing is reasonably high. If it was very low, one would have expected it to take most of the 10 billion years available.
أم خلقوا من غير شيء أم هم الخالقون أم خلقوا السماوات والأرض بل لا يوقنون.
On the other hand, we don't seem to have been visited by aliens. I am discounting reports of UFOs. Why would they appear only to cranks and weirdos? If there is a government conspiracy to suppress the reports and keep for itself the scientific knowledge the aliens bring, it seems to have been a singularly ineffective policy so far. Furthermore, despite an extensive search by the SETI project, we haven't heard any alien television quiz shows. This probably indicates that there are no alien civilizations at our stage of development within a radius of a few hundred light years.
ومن آياته خلق السماوات والأرض وما بث فيهما من دابة وهو على جمعهم إذا يشاء قدير.
If we are the only intelligent beings in the galaxy, we should make sure we survive and continue. But we are entering an increasingly dangerous period of our history. Our population and our use of the finite resources of planet Earth are growing exponentially, along with our technical ability to change the environment for good or ill. But our genetic code still carries the selfish and aggressive instincts that were of survival advantage in the past. It will be difficult enough to avoid disaster in the next 100 years, let alone the next 1,000 or million. Our only chance of long-term survival is not to remain inward-looking on planet Earth, but to spread out into space.
ألف لام را تلك آيات الكتاب وقرآن مبين ربما يود الذين كفروا لو كانوا مسلمين ذرهم يأكلوا ويتمتعوا ويلهيهم الأمل فسوف يعلمون.
Assalamu alaikum, my brothers and sisters. My name is Professor Stephen Hawking. I have spent my life searching for answers to life, the universe, and everything. And now my search is finally over. I have finally read a book called the Quran, and may I tell you, brothers and sisters, Islam is the truth. As you know, I have a keen interest in black holes, and it was black holes which led me to Allah, the Beneficent, the Most Merciful. The Quran says, the place where the stars fall. How could black holes be described in such accurate detail? And for example, the miracle of the pharaoh, how could Muhammad have known that the body of a pharaoh would be mummified? And what about the miracle of the two waters which do not mix? I cannot explain the presence of this information in this holy book, except that it came from God the Creator. Allah. I mean, how else could an illiterate man have possibly known these things over 1400 years ago? Finally, it was the description of the creation of the universe which led me to the one true religion. The Quran says, He created the heavens and the earth from nothingness. It has always bothered me, how can something come from nothing? And now I know the answer. Allah. So I have something to say. There is no God but Allah, and Muhammad was his messenger. I implore you to follow my example. Please put down your science books. There is only one book you need, and it is called the Quran. Everything you could possibly need to know is written in it. Trust me, I am Stephen Hawking. At least now I can grow my beard. Believe me, shaving every day was a right pain in the ass.
A few years ago, I was at a conference and taking questions at the end, and I don't usually get hostile questions except from religious people, and they're extremely easy to handle. But then I got a hostile question which was not so easy to handle. It was a very tricky and a difficult question, and I thought, who is this? It turned out to be one of those I'm an atheist but questions, which are always the most difficult to deal with. It was, of course, Lawrence Krauss. I'm delighted that Lawrence is talking to us today. Please welcome.
I'm going to talk about our modern picture of cosmology and how it's changed our view of the universe, the past and the future. And the observation was that the universe was static and eternal. That was the conventional wisdom in science at the time, that the universe had been around forever and would be around forever. And that's the reason why I, as a particle physicist, got involved in cosmology, because I wanted to be the first person to know how the universe would end. It seemed like a good idea. The universe must be flat. In fact, it's right now we know to an accuracy of better than 1%. The universe is flat. It has zero total energy, and it could have begun from nothing. You don't need a deity. And in some sense, how that picture is clearly remarkable, and far more remarkable than the fairy tales that are made up in most religious situations.
يوم نطوي السماء كطي السجل للكتب كما بدأنا أول خلق نعيده وعدا علينا إنا كنا فاعلين.
when we look at other galaxies, we'll see them coming in toward us on a collision course.
All of a sudden we see stars coming at us from all directions.
All the galaxies will start colliding, and the stars within them will get crunched together.
إذا السماء انفطرت.
The stars will collide, the planets will collide, planets will get swallowed by stars.
وإذا الكواكب انتثرت.
All of a sudden temperatures begin to rise. All of a sudden the oceans boil.
وإذا البحار فجرت.
All of a sudden the mountains will melt.
ويسألونك عن الجبال فقل ينسفها ربي نسفا.
All things must pass.
إن الساعة لآتية لا ريب فيها ولكن أكثر الناس لا يؤمنون.
If the universe collapses, what might subsequently follow is another Big Bang, another expansion event.
كما بدأنا أول خلق نعيده وعدا علينا إنا كنا فاعلين.
Clocks run at different rates in different gravitational fields. The stronger the gravitational field, the more slowly time passes relative to someone out in space where there's no gravitational field.
إنهم يرونه بعيدا ونراه قريبا وإن يوما عند ربك كألف سنة مما تعدون. ويوم تقوم الساعة يقسم المجرمون ما لبثوا غير ساعة كذلك كانوا يؤفكون. وقال الذين أوتوا العلم والإيمان لقد لبثتم في كتاب الله إلى يوم البعث فهذا يوم البعث ولكنكم كنتم لا تعلمون.
This tells us that we are more insignificant than we ever imagined.
لخلق السماوات والأرض أكبر من خلق الناس ولكن أكثر الناس لا يعلمون.
The largest energy in the universe, 70% of the energy in the universe, resides in empty space. And we don't have the slightest idea why it's there. We should realize that there's more we don't understand about the universe than we do.
ما أوتيتم من العلم إلا قليلا.
And far more remarkable than the fairy tales. And far more remarkable than the fairy tales.
إذا تتلى عليه آياتنا قال أساطير الأولين.
I don't usually get hostile questions except from religious people, and they're extremely easy to handle.
إنما أنا بشر مثلكم يوحى إلي أنما إلهكم إله واحد. ولو ترى إذ الظالمون موقوفون عند ربهم يرجع بعضهم إلى بعض القول يقول الذين استضعفوا للذين استكبروا لولا أنتم لكنا مؤمنين. إن وعد الله حق فلا تغرنكم الحياة الدنيا ولا يغرنكم بالله الغرور.
محمد وآل محمد يا مسلمين صلوا عليه اللهم صل على محمد وصح محمد يا مؤمنين صلوا عليه. لطيف خبير سميع بصير جليل رقيب مجيب.
Mount Wilson Observatory in Southern California. The observatory offered some of the most advanced technology of the time. Using George Ellery Hale's magnificent telescope, Hubble photographed the nebulae, faint clouds of light that were a mystery to astronomers. When Hubble examined his photographic plates, he discovered a Cepheid, a kind of star that varies in brightness over a period of time. Hubble studied the variation in brightness and used the data collected to calculate the distance to the star. By his calculations, this star and the galaxy it's a part of were much further away than anyone had ever imagined, and the universe was much larger than the Milky Way galaxy.
What he found was that the distance to M31, the Andromeda galaxy, one of, turns out, our nearest neighbors, is about 2 million light years. So people had been talking about the scale of our galaxy, 10,000, 20,000, 30,000, maybe 100,000 light years. What this meant was that M31 and all those other galaxies were not part of our system. They were themselves big systems equal to the Milky Way.
Scientists now know that there are billions of galaxies, and each galaxy has hundreds of billions of stars. Hubble's discovery of the stunning size of the universe and the massive number of star systems within it revolutionized our picture of the cosmos. That discovery alone would have made Hubble one of the great astronomers. But he continued to study distant galaxies and made an even greater discovery. For 5 years, he gathered data on the movements of galaxies, recording their path and direction by studying the wavelengths of light. Different wavelengths of light appear as different colors of light. If a galaxy is moving away, its wavelengths of light are lengthened. This light appears redder. The faster the galaxy is moving away, the redder the light. If a galaxy is moving closer, the light wavelengths are shortened, so the light appears bluer.
After many years, Hubble could sit down and look at this great quantity of information, and he plotted a chart. He plotted for the nebulae the motions against the distances, and he found something truly amazing, a straight line.
He found that the distance of a galaxy is proportional to its velocity. So as you go twice as far out, turns out the velocity is twice as big. You go 3 times as far out, the velocity is 3 times as big. We live in a world, a big world, a universe, where everything's rushing apart, and it's happening in a way we call Hubble's law, where the velocity is proportional to the distance.
Hubble's startling discovery means that the universe is expanding. And that concept forms the basis of the Big Bang Theory, which says that the universe began between 10 and 20 billion years ago from a state of enormous energy, density, and compression, and it has been expanding ever since.
3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
On April 25, 1990, the NASA crew aboard the Space Shuttle Discovery deployed the famous telescope named after Edwin Hubble. It orbits about 380 miles above Earth's surface. That high up, the Hubble can view the cosmos unobscured by Earth's atmosphere, 24 hours a day, 365 days a year. Technology has advanced since Edwin Hubble's time, but the work remains the same. The telescope's job is to collect images of stars in distant galaxies. These images help astronomers measure the age and size of our expanding universe.
بسم الله الرحمن الرحيم والسماء بنيناها بأيد وإنا لموسعون
الله أكبر الله أكبر لا إله إلا هو الملك القدوس الله أكبر الله أكبر يا رحمن ارحم ضعفنا
سنريهم آياتنا في الآفاق وفي أنفسهم حتى يتبين لهم أنه الحق أولم يكف بربك أنه على كل شيء شهيد.
We shall show them our portents on the horizons and within themselves, until it will be manifest unto them that it is the truth. Doth not thy Lord suffice, since he is witness over all things?
We learn in school about the coherent water cycle. This was first described by Sir Bernard Palissy in 1580. And he said, how does water evaporate from the ocean? Forms clouds, the clouds move in the interior. How do they fall as rain? The rainwater flows into the ocean, and the cycle is completed. Previously, people thought, in the 7th century BC, phase of Meletus, he said that the spray of the ocean was picked up by the wind and it fell into the interior as rain. People did not know how did the underground water, the springs, where did they come from? So they thought that due to the pressure of the winds on the water, the thrust of the winds on the water, it fell into the interior as rain. And this rainwater seeped into the soil and returned to the ocean through a secret passage, the abyss, which was known at the time of the plateau as Tartarus. People believed in this theory of Descartes even till as late as 17th century. And philosophers like Aristotle's theory was believed till as late as 19th century, that water vapor evaporated from the soil, it condensed in mountain cavern, and these mountain caverns formed lakes which fed the spring water. Today we know that the underground water, the springs, it is due to the seepage of the rainwater. And the Quran says that in Surah Al-Zumar, chapter number 39, verse number 21. Seest thou not that it is Allah who sends down rain from the sky and seeps it in the sources in the ground, in the springs in the earth, and causes sown field of various colors to grow. The message is repeated in Surah Rum, chapter number 30, verse number 24. Allah sends down rain and dead earth brings it back to life. The Quran says in Surah Mu'minun, chapter number 23, verse number 18, that it is Allah who sends down rain in due measure. We are able to store it and we are also able to easily drain it. The Quran says in Surah Al-Hijr, chapter number 15, verse number 22, it says that we send fecundating winds, wind impregnating, and cause rain to descend from the sky and give you water in due measure. The Arabic word lawaki used here is the plural of laki, derived from lakaha, which means to impregnate or to fecundate. The winds carrying the pollen, they impregnate the clouds and then rain falls. The wind causes the clouds to merge. There's condensation, there's lightning, and rain falls from the clouds. The Quran describes the complete water cycle. How does the water evaporate, how it forms clouds, how it moves in the interior, how it falls down, how it flows back into the ocean, in several places. In Surah Nur, chapter number 24, verse number 43. In Surah Naba, chapter number 78, verse number 12 to 14, as well as in Surah Rum, chapter number 30, verse number 48. The Holy Quran says in Surah Nur, chapter number 24, verse number 43, that we send mountain masses of clouds. What does the Quran mean by saying we send mountain masses of clouds? Today, if anyone has been traveling in an aeroplane, he will realize that when the aeroplane goes above the clouds and he looks at the clouds beneath, he will see that the clouds appear as mountain masses. Quran has said this 1400 years ago. There wasn't an aeroplane 1400 years ago. Quran describes hydrology and water cycle in several places in great detail. It's mentioned in Surah Al-Imran, chapter number 3, verse number 9. In Surah Araf, chapter number 7, verse number 57. In Surah Rod, chapter number 13, verse number 17. In Surah Furqan, chapter number 25, verse number 48 and 49. In Surah Fatir, chapter number 35, verse number 9. In Surah Yasin, chapter number 36, verse number 34. In Surah Jashia, chapter number 45, verse number 5. In Surah Qaf, chapter number 50, verse number 9 and 10. In Surah Waqia, chapter number 56, verse number 68 to 70. As well as in Surah Mulk, chapter number 67, verse number 30. The Quran describes the hydrology and water cycle in great detail.
But for the earth to have life, it had to have water. Where that came from is one of the great mysteries of science. There are currently more than 1,000 trillion liters of water on the planet. But many astronomers think that if the early Earth contained water at all, it had very little. At the time the Earth was forming, the inner solar system was too hot for liquid water to exist. The region from the Sun to the asteroid belt was almost bone dry. The nearest water reserves to the Earth were now 250 million kilometers away in the outer asteroid belt. Out here, far from the Sun's heat, water froze and was incorporated into the forming planets and other objects. But how the water traveled from here to the Earth is a mystery scientists are only just beginning to solve. One clue came with the blastoff in January 2005 of an unusual NASA spacecraft. Named Deep Impact, its mission was to fly 430 million kilometers to a comet named Tempel 1 and launch a 360-kilogram copper impactor into its nucleus. The mission was the latest attempt to understand some of the most mysterious objects in our solar system. For centuries, people had argued that comets had brought water to Earth. When they looked at the Moon, it was clear from the craters that its surface had been bombarded by large objects. Similar objects must also have hit the Earth, although our planet's much more dynamic geological activity has since erased all trace of them. Scientists also felt certain that comets contained water in the form of ice. But the Deep Impact mission was the first time anyone had probed inside one. On the morning of the 4th of July 2005, NASA scientists waited anxiously as the impactor approached the comet at a speed of 37,000 kilometers per hour. It scored a direct hit. The explosion was captured by telescopes around the world, and analysis of the debris confirmed that comets contain significant amounts of water. But could they have brought that water to Earth? Using radio telescopes, astronomers have studied the type of water in the vapor trails of comets, trying to find out if it matches the water on Earth. So far, scientists have only analyzed 3 comets, but the results are not encouraging for the comet theory. The water in all these comets was not the same as the water in our oceans. The comet theory isn't dead, but it's losing steam. But in its place, scientists have evolved an exciting new idea. A vital clue arrived on the 18th of January, 2000. That evening, the sky above Western Canada lit up with a bright light. Dozens of witnesses saw a meteorite enter the Earth's atmosphere. Seconds after the event, local photographers took these pictures of the trail it left in the sky. As it fell to Earth, the meteor broke up into dozens of pieces and landed on Tagish Lake in British Columbia. Within days, Scientists were on the scene extracting the frozen remains. The pieces they pulled from the ice were the best preserved meteorites ever recovered. Still intact, a piece was shipped to NASA's laboratories at the Johnson Space Center in Houston. Here it was examined by space scientist Michael Zelensky. The meteorite was remarkably undamaged, despite heating up through friction as it entered the Earth's atmosphere.
The meteorites, they're cold soaked in space for millions of years. So they're very, very cold. And they enter the atmosphere at high velocity, and they do in fact get very hot on the outside. But they're only heated for a few seconds. And that's not long enough for the heat to get all the way in past a few millimeters, actually.
This means that when meteorites hit the ground, they cool very quickly.
You hear of reports of meteorites causing fires on the ground, things like that. That's always wrong. They're actually quite cold to the touch after a few seconds.
But when a meteorite is fragile, like the one at Tagish Lake, where it lands makes all the difference.
Very lucky it fell in a frozen lake. If it had fallen anywhere else, it would have easily fallen apart to dust in a few days. And so it's quite possible this kind of meteorite falls to Earth very, very commonly. It's just usually destroyed.
Because the inside of the meteorite remained frozen, Zelensky was able to analyze what it was made of.
This is a sample of the Tagish Lake meteorite. The black material here is mostly clay minerals, the kind that you'd find in your yard. And these clay minerals contain water molecules trapped inside. And so about 20% of this meteorite by weight is water. That's a huge amount.
From the location and angle at which the meteorite fell, astronomers were able to trace its orbit back into space. They discovered that it came from the outer reaches of the asteroid belt.
If you do telescopic observations of asteroids, what you find is, as you move farther and farther from the sun, the asteroids have more and more water.
Astronomers now suspect that asteroids from this outer part of the belt brought water to Earth. If they're right, our oceans came from space in a torrential shower of meteorites. But one question remains. What could have caused so many asteroids to swing out of their orbit and come crashing to Earth? The culprit appears to be the biggest planet in the solar system. Jupiter lies just beyond the asteroid belt, and its mass is so great that its gravity disrupts the path of any object it comes near. In the distant past, it pulled thousands of asteroids out of their normal circular orbits into elliptical orbits that crossed the path of the Earth. When that happened, collisions were inevitable. The Earth was bombarded. As the asteroids crashed to Earth, they smashed apart, and the water inside them escaped. Explosion by explosion, they created the oceans we see today.
ثم قست قلوبكم من بعد ذلك فهي كالحجارة أو أشد قسوة وإن من الحجارة لما يتفجر منه الأنهار وإن منها لما يشقق فيخرج منه الماء وإن منها لما يهبط من خشية الله وما الله بغافل عما تعملون
3/4 of Earth is covered in water. It's why it's called the Blue Planet. But 4.5 billion years ago, when our planet was born, it was just a molten inferno. There was no place for any liquid water at all. Yet the ingredients needed to create water were there, locked away deep inside the Earth when the planet formed. As the first volcanoes erupted, one of the gases that billowed out was steam. And as the planet cooled, it formed clouds. It rained for thousands of years. As the first rivers formed, they began to fill up the lower-lying areas on our young planet, possibly creating the first oceans.
أعوذ بالله من الشيطان الرجيم أأنتم أشد خلقا أم السماء بناها رفع سمكها فسواها وأغطش ليلها وأخرج ضحاها والأرض بعد ذلك دحاها أخرج منها ماءها ومرعاها والجبال أرساها متاعا لكم ولأنعامكم
Our planet was born in fire, then grew with disaster. Yet even then the elements of life were present. Water was soon present on the surface. When calm, it would provide a sheltered cradle for the first life on Earth. Four and a half billion years ago, the Earth was a very different world. Under layers of thick gaseous clouds was a planet still hot from its birth, with an atmosphere both dense and crushing. The early planet was probably only a tenth of the size that it is today. But it was to grow, and that chance and violent growth would prove crucial to life's history and to what we are today. The early solar system was far more crowded than now. Where today the four inner planets orbit, 4.5 billion years ago were scores of smaller planets orbiting the sun. Orbits of some were drawn by gravitational force towards each other. Encounters of awesome magnitude were unavoidable. The force and heat of those collisions melted the rock, but gravity would hold the two together and then weld them into one. With each collision, the planet would grow larger. We believe that of the four innermost planets, Mercury was formed by only 1 or 2 such collisions, while Venus, almost the size of Earth, was formed by 8. Mars may have escaped any collisions. But Earth grew largest, perhaps from as many as 10 impacts. And the last impact, 4.5 billion years ago, would have a profound effect upon our world. The giant body crashed into the center of the planet and gave Earth its iron core. The lighter debris was cast off into space and then drawn into orbit around the enlarged planet. For some millions of years, the Earth had rings like the planet Saturn. Smaller collisions continued, and from that debris was born our moon.
At the Earth's center is a massive ball of iron, known as the core. An outer core of molten iron swirls around it. Next is the mantle, slow-moving, hot rock, 1,800 miles thick. In contrast, the crust, the part we live on, is thin. In fact, it's broken into pieces called plates. 4.6 billion years ago, a continual rain of meteorites pounded the molten Earth. Each strike brought with it more rock, making our planet bigger and scattering metals over the surface. Then, a giant asteroid struck. Its massive iron core didn't stop on the surface. It sank towards the center, and it attracted all the Earth's metals to it as it went. The asteroid's lighter, rocky debris went spinning around the Earth. The fragments were drawn together by gravity. Within a year, they formed our moon. That's why the moon has no metal at its core. And it's why metal is rare in the Earth's crust. It arrived much later, in meteorites from outer space. If we want much more metal, we must go to the Earth's core. It's made mostly of iron and nickel, but 1% is gold. That may not sound like much, but the core is so vast that its gold could cover all the land on Earth, knee-deep.
أشهد أن محمدًا رسول الله.
بسم الله الرحمن الرحيم
وهو الذي مرج البحرين هذا عذب فرات وهذا ملح أجاج وجعل بينهما برزخا وحجرا محجورا.
And he it is who hath given independence to the two seas, though they meet, one palatable, sweet, and the other saltish, bitter, and hath set a bar and a forbidding ban between them.
Underwater caving is notoriously dangerous. When the nearest exit may be hundreds of meters or more away, running out of air down here would be fatal. Cave exploration often requires you to push yourself through narrow gaps in the rock. Cavers call such places squeezes. The tighter the squeeze, the greater the chance of damaging some vital life support system. The flooded caverns can play tricks on you in other ways. What seems like air isn't. It's just another kind of water. This is a halocline, a meeting of fresh and salt water. Fresh water from the jungle flows over the heavier salt water from the sea. The saltwater layer is extremely low in oxygen, making it a particularly difficult place for animals to live. Yet some have managed it, like the remipede, one of the most ancient of all living crustaceans.
Small talk, very small talk. Scientists have long studied how various creatures communicate. Dolphins in the water, chimpanzees on land, birds in flight. But insects, could they possibly have anything to say? Well, when it comes to the tiny ant, it turns out the answer may be yes. Here's Nick Watt.
Ants live in highly structured societies. They are masters of architecture and even agriculture. And now, scientists tell us, ants actually talk to each other.
إذا أتوا على واد النمل قالت نملة يا أيها النمل ادخلوا مساكنكم لا يحطمنكم سليمان وجنوده وهم لا يشعرون.
Were you surprised by what you found?
We were. Yes, we were surprised.
Absolutely.
وتلك الأمثال نضربها للناس وما يعقلها إلا العالمون.
مولاي صل وسلم دائما أبدا على حبيبك خير الخلق كلهم. مولاي صل وسلم دائما أبدا على حبيبك خير الخلق كلهم. محمد سيد الكونين والثقلين. محمد سيد الكونين والثقلين والفريقين من عرب ومن عجم. مولاي صل وسلم دائما أبدا على حبيبك خير الخلق كلهم. مولاي صل وسلم دائما أبدا على حبيبك خير الخلق كلهم. أوذيت في الله لم تهزم ولم تهني. أوذيت في الله لم تهزم ولم تهني حتى غادت أمة الإسلام في النجوم. مولاي صل وسلم دائما أبدا على حبيبك خير الخلق كلهم. مولاي صل وسلم دائما أبدا على حبيبك خير الخلق كلهم. حبيب الله رسول الله إمام المرسلين. حبيب الله رسول الله إمام المرسلين. سريت من حرم ليلا إلى حرم كما سرى البدر في تاج من الظلم. سريت من حرم ليلا إلى حرم كما سرى البدر في تاج من الظلم. وبت ترقى إلى أن نلت منزلة. وبت ترقى إلى أن نلت منزلة من قاب قوسين لم تدرك ولم ترام. مولاي صل مولاي صل وسلم دائما أبدا على حبيبك خير الخلق كلهم. جئنا إلى الدنيا كي ندعو إلى الله،
لننشر الخير في الكون الذي حارى،
ونرسل العطر من روض الهدى الزاهي،
ويشرق السلم أنوارا وأنوارا.
جئنا إلى الدنيا كي ندعو إلى الله، لننشر الخير في الكون الذي حارى، ونرسل العطر من روض الهدى الزاهي، ويشرق السلم أنوارا وأنوارا. الله 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 أكبر، الله 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 أكبر، لا إله إلا الله، لا إله إلا الله. إسلامنا جاء ليبقى السلام ضياء ونورا في دنيا الظلام.
إسلامنا جاء ليبقى السلام ضياء ونورا في دنيا الظلام.
فالعدل منانا ما بين الأنام، لنحيا جميعا في ظل الوئام، لنحيا جميعا في ظل الوئام.
الله أكبر، الله 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 أكبر، لا إله إلا الله، لا إله إلا الله.
أوصانا النبي وخير الصحاب أن نرقى جميعا أعالي السحاب.
أوصانا النبي وخير الصحاب أن نرقى جميعا أعالي السحاب،
ونزرع الحق في كل رحاب، لنحصد النور ونجل الضباب، لنحصد النور ونجل الضباب. الله أكبر، الله 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 أكبر، لا إله إلا الله، لا إله إلا الله، لا إله إلا الله، لا إله إلا الله.
رسالة الدين في هذا الوجود أن يهزم الظلم وتلغى الحدود.
رسالة الدين في هذا الوجود أن يهزم الظلم وتلغى الحدود.
والطير يغني من غير قيود في كل سماء، والحق يسود في كل سماء، والحق يسود.
الله 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 أكبر، الله 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 أكبر، لا إله إلا الله، لا إله إلا الله، لا إله إلا الله.
ليكن يومك للشعب ودادا، ليكن حبك للأرض مداد، للأرض مداد. قلم أنت فكم عبرت عنا، وبنيت المجد أطوادا شداد، أطوادا شداد. أنت يا ملهم شعب أن يبروا، عشت كم حققت للشعب مراد، للشعب مراد. ليكن يومك للشعب ودادا، ليكن 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 حبك للأرض مداد. قلم أنت فكم عبرت عنا، وبنيت المجد أطوادا شداد. أنت يا ملهم شعب أن يبروا، عشت كم حققت للشعب مراد.